Hi, it's Vinny from Electronic Principles here. Today is our first day of the restoration project of the Bosch VHF90, and to start we're gonna be removing the speaker, the audio transformer and the front panel from the enclosure, and we're gonna cook this enclosure for a few days in a bath with warm water, chlorine and hydrogen peroxide. The chlorine and hydrogen peroxide are gonna attack the tarnish on the enclosure, and hopefully after a few days we're gonna have a whiter enclosure, more similar than when the radio was produced. After that, we're gonna start dismantling the chassis. We're gonna remove all the tubes, and we're gonna remove all the circuits to starting cleaning the chassis from scratch. So let's go now, starting working on the enclosure and removing the parts that are here yet. So you can see here that we have the glass front panel. They have some holders missing, and we're gonna be working on these holders in next episodes. So for now we are just gonna remove everything from here. So the glass display is removed. Now let's work on the audio transformer. I'm gonna cut the wire from the transformer to the speaker. Now we have our audio transformer. Remove it. Okay, so the speaker was removed, and we can see that despite the fact that it's very dirty, the diaphragm, the cone is in pretty nice condition. So we're gonna treat before we assemble the radio again with some rubber cement to make this cone stronger. But for now we're gonna keep this aside, and we're gonna continue in the radio. So next thing, here the protection for the speaker is actually a separate part, so I'm gonna be unscrewing it, because to remove the AM ferrite antenna, probably I'm gonna need to remove this grid. So remove it. No, I think you are gonna need to remove the antenna to be able to remove the front grid. So there are some nuts here, there's no screw, so I'm gonna need to use a plier. So this is the ferrite antenna. This is responsible for the AM band in the radio. We have two antennas, one for the FM band, VHF, and we have for long waves this ferrite antenna. A nice thing about this enclosure is that they used metal inserts on the threads, so we're actually not in the risk to damage the screws, the threads, because just on this grill we see that they are threading directly on the grid, but in the most important parts in the radio, like the chassis, everything is metal inserts. So pretty nice to see that. Okay, so the enclosure is totally dismantled right now. I have some metal grips here. Let's see if I can remove them. Okay, it's a bit tricky. remove. The first one is spring arrow, second one removed. So now we're gonna prepare our bath to make it this radio, this enclosure whiter. So first thing that I'm gonna be using is a bottle of creamy hydrogen peroxide. This was the only one that I found on the supermarket, but you can use liquid also. So you can use 40 volumes hydrogen peroxide. One bottle of this is enough. And I'm gonna use this bottle to measure the chlorine, and I'm gonna use more or less half of this bottle. If you see that your enclosure is oily, you can put a bit of soap to help to remove. But for now, this would be enough. So I'm gonna be putting here the enclosure on the bath. This is warm water, but actually it doesn't matter. It's just to help to dissolve the dust better just now, and when it's cooler, just the chlorine and the peroxide are gonna be working on. So I put the grade 2 here. So now I'm gonna get the knobs and the black clear plates of the knobs. So here we have the black clear plates and the knobs. So I'm gonna put them entirely here in the solution. Okay, so this is our first part, and now we are gonna be working on the chassis, and we're gonna start dismantling the chassis. Okay, here we have our chassis from the Bosch VHF90. So let's start dismantling this chassis. First thing that I'm gonna do is remove the tubes carefully. So here is our audio tube. Here we have one of our IF amplifiers, another IF amplifier tube. It's important when the tube is tight is to bounce very slowly in just a small angle and push up the tube so we don't risk to damage the tubes. These are rectifier. Okay, the last one is the high frequency VHF oscillator and mixer. Now that our radio is safe from the tubes, so we don't risk to damage them, let's start dismantling. First I'm doing just a visual inspection to see where we can start easily. So I'm gonna remove this shield. Because the wires are in pretty nasty condition, I'm gonna be removing all the circuit. So I'm replacing all the capacitors and resistors. This is a lot of work, but I'm thinking is gonna be valuable on this case, because I'm gonna be replacing all the wires. So we're gonna have an entirely brand new circuit. So first transforming coming out. One of the coaxials here I'm removing. The high frequency on this radio is totally isolated in an aluminum casted box. So let's see if I can easily remove this box. This radio is very interesting because it has a variable capacitor for the AM sector, and they use a variable inductor for the FM sector. So basically it's a hybrid approach for tuning. We have a string that goes to the core of the variable inductor, and since that one of the sides is held in place by a spring that pulls back, so I think I'm gonna need to remove the variable capacitor string here. So here we can see the coupling for the variable inductor with the variable capacitor. So I think now we are loose free. Okay, so our first major part here. So this is the high frequency box. So here is where we receive from the antenna the VHF signal, and we have here the first transformer, antenna transformer. It's a balloon, and we have our tube here that is a mix of oscillator and mixer, and we have our first IF transformer. And this side we have the mechanism for the variable inductor. So as you can see, when we pull here, it's gonna actually change the inductor inside, and we're gonna change the selectivity. So I'm gonna be opening this case. Let's see what it has inside. The nuts are breaking loose on the back, so first I'm just bring everything here. Okay. So here we can see the mechanism for the variable inductor. Is pretty neat. As you can see, we have a spring here. We have the two inductors. So probably one is for the first oscillator, FM oscillator, and another one is for the tuner, so the tank circuit. Let me see if we have some critical components, some capacitors here. So maybe I need to check this yellow sleeves here, but since that we just have some ceramic capacitors, maybe mica, I'm not sure yet. I'm gonna need to check on the datasheet these components, but yeah, so let's keep this aside for the moment. It's pretty cool implementation. I really like the way that they did, pretty neat. So let's continue in the main chassis. So since we are working here on the tuning circuit, let's remove the tuning string. This plastic goes to our bath also. There's another. Oh no, it's not a plastic. Here they have a painted aluminum front. Probably is to reflect the light. So let's start cutting this capacitor. So here we have our variable capacitor. So it is designed to tune and to control our variable oscillator for the AM circuit, so low frequency circuit. So yeah, it's looking nice. Of course, some cracking rubber here that we're gonna need to replace, probably is isolation. But the capacitor itself looks nice, just a clean, and it's gonna be good to go. There's mostly cracking wires and itself, so we're ready for lights. there's no lights. I'm planning to replace this for LEDs. So I think with this radio originally has very dim light in the display, and I think if we substitute for LEDs, it's gonna be awesome. So yeah, I'm gonna be doing that. Okay guys, just to let you know, despite the fact that I'm gonna be replacing this entire circuit with brand new components, I must say that I took many pictures to assist me when I'm gonna be rebuilding the circuit, okay? It's very hard to do from scratch from the schematic, so of course when we have pictures, always helps. So here we have our main capacitor, of course is end of life, so we're gonna need to put a brand new here, so maybe we're gonna keep this one just for aesthetics, or maybe not. Maybe it's better to keep outside and give more space for the radio to breathe, you know. Okay. You can see that I'm not using the right tool and using a plier to remove the switch. I don't recommend that, but well, I don't have the right tools. So yeah, patience. I already put contact cleaner yesterday, so yeah, it's spinning very smoothly. So let's see when we assemble the radio and put it to work to see if we're gonna have any kind of cracking. But I'm feeling lucky with the switch. This board is responsible to change the mains voltage. So basically it has some resistors here, so if we tap here in the different positions, we change the filament voltage. Okay, so these resistors are limiting the current when the voltage is higher than the nominal. So the upper faces is almost empty. We just need to remove the IF filters right now. So our first IF filter is out. Second one. Okay, third filter. One of the filters has a double shield, so I imagine that the coupling on this filter is very critical. Oh no, actually this filter is bigger, so the reason that it has a bigger cam is actually because the filter is very large. Our chassis is almost clean, so let's go to the bottom again. We're gonna remove this switch. This radio has a design flaw. When it gets old, it has a problem that the FM band starts cracking, and the reason is that one of these switches, one side is the band selector for the FM, and another side is the high voltage to enable the amplifier sector of the FM. And because the distance here is very small, when this switch gets old, it's starting leaking current from the high voltage to the FM signal. So what happens is, with this leakage, the radio starts cracking, and basically is irreversible. So what we can do, we can actually change the positions of the switch, so we can match the switch to keep the high voltage in one place and keeping the small signals in the another place, so we can solve this problem. And here you can see that the distance between the two plates from the two switches is like 2 millimeters. So this, with time and with the humidity, it's started leaking current, because one of the sides is very small signal and another one is high voltage. So this is starting like cracking and making noise on the radio. So we're gonna address that when we rebuild the radio. Very hard to do this on camera. Okay, I just broke the standoff. Not an issue. Very easy part to replace. So broken standoff. Let's cut this bar loose. Okay. You can see that this region here is very dark. The reason is, this is another issue with this radio, is that they put some power resistors in the bottom side of this radio. So we're gonna try to address this. So power resistors that we can put on the upper side, we're gonna put. So let's make this radio better. Right. Remembering that this is the easiest part. Rebuild this thing is gonna take hours. The chassis is ready to be cleaned. Okay, so we finished to remove all the components, all the wires, transformers, all the mechanical parts from the chassis. On the next episode, we're gonna be cleaning all this chassis, cleaning all the individual parts, and after that we're gonna start effectively rebuilding the circuit from scratch with new components, replacing the wires and putting this radio to work. So if you like this content, please subscribe to the channel. If you want to give any suggestion, please give a comment, and if you like, thumbs up. Thank you.